people who are studying the evolution of codes and communication in biology. And then finally, we've got the black bear, which I'll talk about on the next slide here. So how do communication systems evolve? In signaling theory, communications start out with cues, and those eventually evolve into legitimate signals. And this is an example from my childhood. I'm going to start out with an example from two thinking creatures. So we're going to use our brains to invent a communication system. And then we'll talk about how communication systems can evolve between things that don't know how to think at all. They don't have that ability to think at all. But when I was a kid, I used to go camping a lot. I was a Boy Scout. And we were told that there's bears in one of the areas that I was camping at. And it turns out that bears are scared of humans. They avoid humans if they know that humans are around. But if you surprise them, if you just happen across the bear, a lot of times it will attack you because it's scared. So they've got this fight or flight response. If you're close enough, they'll fight you. If you're far enough, they'll run away. So the bear wants to run away from you. It does not want to interact with you. But if you're just walking through the woods quietly, like you normally would, you can end up getting killed by a bear. So we were told to signal to the bear that we were present. And we would do this by singing when we were walking in the woods. We would do this by talking. Some people would put bells on their shoes, things like that. There are different ways that you can signal to the bear that you're there. And that will allow the bear to run away. Now, when all organisms, all things are constantly putting off cues that they exist. So I'm making noise, and another organism that might be in the room could hear that noise and get that cue and hide from me. Maybe there's a spider in the room with me. I'm not trying to communicate with spiders in my room right now. I'm communicating with you guys. So these things that I'm sending out, this noise that I'm making to the spider, that is considered a cue. The spider picks up on it, but I'm not sending it on purpose. Someone walking through the woods, their footsteps are a cue to the bear. The bear can pick up on that, but the person just walking through the woods isn't actually sending a signal. They're just accidentally emitting cues. Predators can use cues to hunt their prey. So there's nothing intentional about sending out a cue. When a sender starts doing it on purpose, when a sender starts actually trying to communicate with the other entity, then we call it a signal. And in biology, we call it a signal when the sender starts magnifying the cue because they're getting some sort of survival benefit from it. Is that clear? So the difference between a cue and a signal, is that clear? Okay, we go to the next slide here. Okay,
I'm just waiting for my rebuttal.
Yeah. I know.
So
be patient. You're doing good. I'm proud of you.
So how is it that communication systems evolve between things that can't think? You know, I was able to develop a communication system with a bear because someone taught me how. So I used my brain to do that, and the bear's using his brain to figure out, you know, what to make of these signals that are being sent his way as well. Well, in bacteria, it turns out when we study the communication system in bacteria, it's very clear that the molecule that they send out is actually just a waste product. It's their urine, essentially. Something that they're just trying to get rid of. They don't want it in their body. Other bacteria evolved a receptor that could receive that urine. We'll just call it urine. It's not actually urine, but receive that molecule. And when it would receive that molecule, they would change their behavior. We now see that these things are actually producing these waste materials on purpose. They're actually producing more than they need. They're actually burning calories to produce these faster than they otherwise would be. And because of that, we now call it a signal. These bacteria, you could say, are doing it on purpose. They've evolved they've evolved the ability to enhance their signal. And so we call it a true signal now. And it turns out that bacteria actually have a fairly complex, some of them have a fairly complex collection of signals and fairly complex reaction to those signals that they send and receive to one another. And all of this is happening without a brain. All of this is happening simply because of descent with modification acted upon by natural selection. Communication systems evolve every time two or more evolving entities have selection pressure to cooperate. And when there is selection pressure and two evolving entities, the communication system will emerge. It will evolve. Or I should say it can evolve, because it's also possible that two organisms live right next to each other and never end up having the right mutations to even know that the other is there. But these are the circumstances in which a communication system can evolve. Furthermore, once you have organisms that can think, they can actually use their brains to develop communication systems much faster than the slow process of evolving a communication system the way that bacteria have to do. But that is signaling theory kind of in a nutshell. And this is how codes evolve. Again, a code is the set of rules that govern a communication system. And next slide here. This is just more on dogs. We're all very well aware. I just want to drive home the fact that a symbol in a communication system does not have to be a letter. It can be a molecule. One of the symbols, there are many symbols in a dog communication system, and they can smell those molecules. They can get all sorts of information. Is the dog in heat? Is the dog bigger than me? And so forth. They can actually recognize each other by these molecules that are in their urine. And again, those molecules aren't a dog in heat. Those molecules are symbols saying that this dog is in heat. It's not an actual dog in heat. It is truly a symbol that the dog can understand. So that's why when you take them out on a walk, yes, yeah, their Facebook, their Twitter is smelling the bush that some other dog peed on. So be nice to your dogs and let them sniff that bush next time you take them out for a walk.
So much like
I'm all into bush sniffing.
Twitter. Yeah, but he's not allowed on Twitter.
Is it
does that wrap? Do you have any more slides?
The next slide. What's the next slide? I've actually got. We're running low on time, and I want you guys
I feel like I've talked to Jeanson. Next slide. Yes. Next slide.
Yeah. Steve, you do the same thing. Is that? Are we getting close to it? I want to be able to have back and forth between us. Okay.
I can end it here, but I've got another section where I talk about translation and transcription and all that stuff, but he already kind of went over that. So
yeah,
and we can get to that in the back and forth. So yeah, perfect.
This is just I want everybody to know. I want everybody to know that this book right here, Behavioral Ecology, is the best book to start if you want to learn how communication systems evolve. And that book's expensive, though. It's a textbook. This paper right here that I'm showing on screen, which I can't read on. Hold on. I've got it here, too. That's a really good paper that gives a good overview. It's called Evolution Theory of Bacterial Quorum Sensing. When is a signal not a signal? And actually, this is a paper by Stuart West where he was just correcting the use of other biologists. They were misusing signaling theory and not understanding it properly. And this he corrects them. And well, actually, Stuart West didn't write it. He was one of the authors on it. It's a really good paper that describes what signaling theory is at its core in biology. So. And that's free. You can just Google that and find it.
Thank you. All right. Okay. All right. So we're running low on time.
I'm done.
Okay. There's not a lot of time for formal rebuttals, and I really want to see the interaction back and forth as you guys ask questions. I'm going to try to argue.
I got to address.
I know, Steve. I know. Just let me finish the sentence, and I promise you can go. So I may interrupt if I feel you're talking past each other so that I can help sort of translate to the audience, but mostly I'm going to let you guys kind of have a back and forth, and Kyle will interrupt if we have any super chats that need to be read, because those take precedence, because those people are kind enough to pay to have the opportunity to ask a question. So I will interrupt you for that, or if I feel like you're talking over each other and nobody can understand what you're saying. So Steve, I will let you take the floor first, because I know you're about to die. So please go ahead, Steve.
No. Not at all, because I think the last 10 minutes.
I'm proud of you.
It's funny you mentioned things like quorum sensing. We actually have a PhD that did their thesis on quorum sensing, and so we've talked about it before. Quorum sensing, as I understand it, is basically if you have a certain amount of chemical that's in the system, like for aspergillus or some kind of bacteria, then it'll signal some kind of thing through a pathway, such as like G protein coupled receptors, right? And I actually did a video on this a long time ago on those very same things. So that is information that has nothing to do with the code. I think what's happening is you're confusing information and signaling, because quorum sensing deals with signaling of those G-coupled protein receptors. Those are not a code, though. The code is how I've explained the code to be. And when you go back a little bit earlier about the ID argument, I'm not arguing from an ID position, and I don't care how the IDers argue it. Codes generally do come from intelligence. Now, again, that's only by strict definition. You can take a more loose definition. But the reason the codes come from an intelligence because the sender and the receiver have to be able to communicate what the message is. And the only way you do that is you give them a code book, right? So there is an understanding. Just because a syllogism is true, that doesn't mean it's convincing. So even if it's the case that a code is by an intelligent mind, it doesn't get you to an intelligent designer because it's just by definition. It's not a convincing argument. For a good argument, you need to be logically valid, it needs to be sound, the premises have to be true, and it needs to be convincing. Argument by definition is not very convincing. So I don't care what the ideas think. The other things I noted here, Deidre Wilson and wrote some things on this. Language is not a code. They actually said coded communication works best when the emitter and receiver share exactly the same code. Any difference between the emitter and sender's code is a possible source of error in the communication process. That's why each has a code book that they use. Quote, human language is not a code. True codes have a one-to-one relationship with meaning. And that meaning is what's important here. One-to-one relationship with meaning. When I convey that car is supposed to represent nuclear weapon, there's meaning there, right? There's no meaning by just a symbol inherent to that symbology. And you talked about how it's not symbols. Yes, it's semiotics. And semiotics is literally dealing with symbols. So when you're talking about codes, you're dealing with symbology. Right? What you're doing, you're taking Shannon's information theory and you're inappropriately relating it to symbology because you're saying there's information in the system. There's information by which these animals communicate with each other. Yes, they have chemical and pheromones they released and they communicate with each other. But I think you're using the word code so loosely that it applies to literally anything at that point. I'm using it in a very specific way. So when you're talking about all these things like quorum sensing, I don't see how it relates in any way, shape, or form to the topic of a DNA as a code. Let's assume there are natural codes. I'm not going to argue either way on that. I'm agnostic on that particular point of view. But if it is the case that if it is the case that it requires an intelligence, it doesn't matter to me. It doesn't help the ID argument at all. It's not a convincing argument to me. Does that make sense?
Steve, you have somebody, and this will let me just break in real quick because there's a super chat that kind of it's relevant to what Steve just said. It said, Steve, do you have a specific definition of code that you use?
Oh, I'm glad you asked. I have a couple, and this is the problem. It depends on what definition you use. He's arguing a specific thing. That definition, I'm saying it depends what you use.
Fit even one of those couple? If you have a couple,
there's a couple. Okay. The main one is this: a system of
what
words.
John is talking.
Go ahead.
Does what John's explaining fit any of those couple definitions?
Well, yes, the same way by which a legal code is. He's talking about hang on, a legal code, but we're not talking. You say, is DNA a code like a legal code? A code means something you have to abide by doing. You have to obey the law because there's a codification of the law, right? It's codified. That's a completely different meaning. That's an equivocation problem there because that's not what we're talking about in symbiotics. That's not what we're talking about in information theory, nor in cryptography. It's a completely different meaning of the word. So he's meaning by which something has to be a signal to do something or an abidance by which you have to obey something. One of the things, the definition for code is programming instructions, right? Or a system, a collection of laws, statutes. Or this one, a set of conventions or moral principles governing behavior in a particular sphere. DNA doesn't apply to any of those things, right? So we're asking if DNA is a code that has nothing to do with those definitions. And I think he's using a weird definition that doesn't apply when it comes to DNA.
I am